Howdy YouTube, it's me again. It's kind of a cloudy, cold, gross day, and I'm just not really building or riding electric bikes at this point of the year here in wonderful Utah. But I wanted to talk a little bit about the ratings of various components used in electric vehicles and how some of them are deceptive and some of them are actually just kind of based on history and not really accurate anymore for our application. Because this has been the reason for debates on the internet for, at least a decade in the e-bike community, and I've been kind of a broken record on my opinions, which are based on a lot of real-world observations, data, and experience. So I just was hoping that I could maybe solve a couple of these debates by making a video about these things. I'll start with the one that kind of gets under my skin the most, and that is batteries. Okay, so this is a nice little Panasonic NCR 18650 PD. I think it might be rated for 2 or 3C, 2.9 amp hours, and just wanted to talk a little bit about how these are rated by manufacturers today. So when they're looking for the power output of a battery cell these days, they're actually basing the power output based on thermal characteristics but not performance. So what they do is they take one of these single cells, they put it in a lab that's temperature controlled, and then they have some kind of device to measure the current and capacity and things like that, and they find out the point at which the battery barely doesn't explode. Right? So this cell here, a reasonable use case of this cell is about maybe 1C. You could technically use it at 3C or whatever it's rated at. I'm just using it as an example, because it will not explode at 3C when it's brand new. Now, the wonderful asterisk here is that as these battery cells degrade over time, as you put the cycles on them and beat on them with your EV, is that their capacity decreases and their internal resistance increases. So as this ages, your 3C is actually more like 2.7, 2.5C after you've got maybe 300 cycles on this. So it's really not a good idea to even use this at 3C in a single cell lab controlled 70 degrees Fahrenheit condition for very long. You can get away with it for a while, but eventually this thing will blow up after maybe 500 cells if you just keep giving it that kind of load. But we do not operate our electric vehicles in temperature controlled labs, and we absolutely do not use one cell to power a thing like an electric bicycle or motorcycle, do we? So there is a big problem with these, in that a lot of manufacturers will go and take the 3C rating and then assemble a bunch of these into a pack and say that the pack is 3C capable. But in this kind of scenario, these are not realistically 3C capable. So this cell right here might be, but the cell in the center of the pack is getting cooked by all these other cells. You never want to use a completed battery pack without some kind of liquid cooling like a Tesla pack at the maximum rate. In addition to all these being sharing their thermal area, this case goes on, and then that's like an additional blanket. So if you can imagine, when you go to bed at night, I know that I like to usually have my bedroom right around 60 degrees Fahrenheit if I can get it, and I throw a blanket on, and then I'm a nice I don't know, maybe 67, 70 degrees Fahrenheit, which is just totally fine. I like having a blanket on me, But imagine, in this battery pack, you've got 70 people all under one blanket, all right jammed next to each other. I wonder, exactly how hot the person in the center would be. They'd probably be sweating their balls off, or their other things if they're But yeah, so that's not a realistic scenario for battery use whatsoever. And the battery pack I showed you is actually a Lunicycle battery pack. Unicycle is one of the largest retailers in the United States of e-bike components, and what they generally do is they take the manufacturer data sheet and just kind of parrot it as a capability of the entire pack, which is very misleading to the public. So I would recommend being very skeptical of these. If you want to find out the truth about the continuous thermal rating of a pack, then you simply just need to look at the data sheet for the cell. So with this cell here, I can take the model number. I don't know if you could see that, and then I could type that plus data sheet, and then I would probably get something from Panasonic within the first couple hits that would tell me what the performance is like at 3C. And I guarantee if you look at that data sheet, the performance is going to be terrible. Even more so in the last couple years, because since these are rated on thermal characteristics, what they've done is maybe in the last 4 years or so, they've come up with some kind of additive to put in the battery to get the point at which the lithium cell starts to degrade from about 60 degrees centigrade to maybe, I don't know, 80 or 90, right? So technically they can say that this battery is capable of more power now because it's not exploding at that power level. But the reality is that the performance of the cell has not increased. You can actually find this in like an old data sheet of one cell versus a newer data sheet of a cell with a different number but the same capacity and the same IR. One of them will claim that it's a 2C cell, and then the next one will claim that it's a 4C. But when you look at the newer cell, you'll see that it sags. The voltage sags when they discharged it, like the really high rates, even more. So they figured out a way to get worse performance and efficiency out of a battery cell so they can claim that it's a higher C rate. So even packs like this Unicycle one that I showed you, they've kind of parroted that semi-misleading claim. And then so when you put that on your bike and you've got a 48 volt battery pack and you're using it at maximum, suddenly it's a maybe 38 or 39 volt nominal battery pack, and you just don't get the capacity or the voltage that you expected. Our forum is absolutely chock full of people complaining about batteries not living up to their specifications, and mechanical issues with the construction, and BMSs going out because they were overrated. And this is just a thing that's going on with the whole industry at this point. I'm not really sure who started this kind of exaggerated claim of the completed battery pack, but it's become a thing where if you don't sell your battery packs that way, then they look not as great as your competitors. So manufacturers that don't have an electrical engineering team or honesty, basic honesty, will just kind of parrot those figures, and it's not a realistic expectation for you riding an e-bike or whatever it is. In reality, once it's assembled into a pack, you really need to derate the heck out of it. Probably, about half of what you expect is what you should be running. So that's just kind of one area where there's a lot of BS going on in battery ratings. Another aspect of this is the capacity of these cells. A lot of big name manufacturers, Panasonic, LG, Samsung, etc., have been marking cells as 3.5 amp hours when they're really 3.4, and you only find that out when you look at the data sheet. And some of these sellers, Unicycle included, have taken the sort of fib scenario of the capacity and just parroted it without really even doing their own independent tests, or maybe just an honesty issue again. So the whole battery industry is really full of these little fibs. And anyone that is honest about these things because they understand batteries and want the customers to have a long-lasting battery and good experience, they're really the exception to the rule. So you should really be skeptical. Another thing you would probably notice is the exaggerated cycle life on these cells. Now, if you look at this data sheet for this cell in particular, you would find that they figured out how many cycles this cell went until it hit maybe 80 or 70% of its capacity at the lowest discharge possible, like literally 0.2 amps half an amp or whatever. And that kind of hides the fact that when you use it at the higher power level, you're going to see like a much lesser cycle life. It might last half as long when you're using it at 3C. So, and you know, oftentimes you won't find any cycle life test at 3C. So what the manufacturer will do is sort of give you the best case scenario for each spec, and then your reality is something completely different. So the best case for power, capacity, longevity, and even safety when we're thinking about the, you know, thermal stuff, is to use the packet at like around half of what is claimed by these major manufacturers. And it's not just like your AliExpress or eBay battery pack chucker that's involved in this. Like I mentioned, the biggest seller in the United States does this, and also almost every of their competitors also have the same claims, because, you know, again, it's a competitive disadvantage if you're honest. So I would really like to see this this trend to end, but I'm not really sure how we're going to get there. Just buyer beware. Now, let's go on and talk about electric motors a little bit different, or a little bit, because here we have actually an opposite scenario in most cases. And this is due to a lot of historical reasons that electric motors were used for. So when the three-phase AC motor was invented by Tesla sometime in the 1800s or whatnot, the main application was to use it as a generator, right? So you had a steam engine or a coal plant, or, you know, some windmill or hydroelectric, and it needed to generate electrical energy continuously for years using a motor. So what you needed to know was how much power can this motor either take in or put out just continuously for years. And that is, you know, if you were to take a motor like that and run it in a electric vehicle with a battery that only lasts an hour, then, you know, you could probably push about 3 times the power and get away with it, right? But sort of as time goes on, we've moved over to maybe a 24 or 48 hour measurement where the electric motor hits this heat stasis point where it doesn't continue to climb, and it just kind of maintains. So even motors like the one in this little fan here that I use in my bedroom, I mean studio office, is rated for a 24 hour period of time, because realistically it could be used 24 hours or even for weeks, right? So I mean, I believe that this is rated at about 15 watts. Now if I were to hook this up to my e-bike and then use it as the worst e-bike motor in the universe, I might be able to get away with 25 or 30 watts, because if my battery only lasts an hour, it never gets hot enough to melt. So that's just fine. So that's the sort of the historic way to rate an electric motor, is to think about it in terms of a 24-hour rating, right? But that's not, you know, I can't think of any instances where I would want to ride my electric bicycles for 24 hours straight, right? Like my rides are usually like maybe 30 minutes, 2 hours max. So a lot of electric motors, even for electric bicycles like the hub motors and whatnot, are rated at a very long time span still. So the motor power ratings are actually kind of deceptively, well, maybe not deceptively, maybe generously understated. Especially once you get into operating the motor for only 30 minutes, where you have a really short battery and a large amount of power. You might be able to get away with just dumping 2 times the power that the motor is rated for, and the thing never really gets hot enough to have any detrimental effects. Even the 24-hour rating versus the 1-hour rating might be, a greater than 50% difference, but we still see electric motors being rated this way. So there actually is a lot of room, a lot of headroom in electric motors versus batteries, where you need to cut tons of headroom out of the specifications. And also there's some other tricks that go in the opposite direction with electric motors, where they'll use a certain kind of rating that's not really truthful, right? So I'll give you an example of going each way. So I have read dyno sheets for tons of motors, trying to find the most efficient and most powerful and lightest one that I can get my hands on that is easy to install on a bike, right? So I'm continuously going through these data sheets looking for the golden ticket. When I found the Leaf motor, a 1.5 kilowatt, I noticed that in the data sheet, or the dyno graph, that they had kind of selected an arbitrary point in the dyno graph where it's like, yeah, it looks like the motor could shed more heat. So I took the dyno graphs of some other kind of regularly rated motors and realized that a motor of the size of the Leaf can shed about maybe 150 or 200 watts. So I went down that dyno graph past the point they selected to the point where it's shedding about 200 watts or so. And I said, okay, that's what it should be able to do continuously. And I was right. Well, right with an asterisk, right? Like, I thought that perhaps it was a 2,000 watt rated motor, but it's realistically more like a 1,900 watt rated motor. I mean, over the course of an hour, right? Which is the use case for most of our bicycles. So I kind of found like a, underappreciated, underrated component that was it turned out to actually be a really amazing motor because of the efficiency curve of the motor, thanks to its design. And in the opposite situation, I had also bought a MXUS 3KW motor, which was just pretty much the same attributes, same wheel size, very similar winding. Actually put it on the same bike, ran the thing for an hour to see what it could take. It seems like it started to conk out and reach about 100 C internally, right around 2.3 kilowatts. So I really wondered why it was that this motor didn't perform as advertised. So what I did was I hunted down a dyno graph for this motor, because usually this company MXUS is very truthful with the ratings, but in this one instance what they'd done is they did the motor test with a 20-inch wheel, which is also known as a 16-inch wheel in the motorcycle world, like for scooters and stuff. And as a lot of us know on Endless Sphere, when you have a smaller wheel, you can increase the RPM and then create more continuous power, or even just make more torque than you did before, so, which is maybe a 20 to 25% advantage. So they had used this advantage to their benefit to rate it at 3 kW, whereas all these other electric bike hub motors are rated for like maybe a 26-inch or 700C wheel. So they had done some intentional deception, and a lot of people bought these motors and thought, oh, this is BS. I'm going to go buy a QS motor, which are said to be very underrated, but I have no experience to speak from. So sometimes there are tricks in motor rating as well. But you really got to get your BS sniffer well tuned to find them, and understand how to read a dyno graph at the least. Or if you don't get one, then maybe you shouldn't buy the component. So yeah, it's rather interesting how there's deceptions and marketing and things going on, even in a sort of nerdy thing like electric vehicle engineering and DIY and it's kind of become a commonplace thing. But really, the amount of time that you operate a component is very critical. So you need to think of how much heat you're going to be generating, like for example in a battery or in a motor. Lucky for us, our motors are usually generously overrated or underrated. Sorry. Here's another interesting scenario. So RC motors, right? A lot of people are fans of kind of building some kind of reduction drive with an RC motor. And these RC motors usually claim like, 10 kilowatt and the thing the size of your fist, right? You also have to consider the thermal situation of an RC motor. Hang on a sec. Yeah. An RC motor is in a vehicle where there's maybe a 100, 150 mile per hour wind rushing by your RC motor. So it's definitely not rated in the same way that a 24-hour generator motor is rated. It's more like what will the vehicle what will the motor tolerate in this specific application. So when people build little mid drives with RC motors, they don't understand that it's being rated for a completely different application in a totally different way. And your 10 kW motor is actually only capable of 2 kW when you have, 40 or 50 miles per hour wind rushing by it. And, and also when you start the electric bicycle, it's using, all the 10 kW, but when you start the airplane, it's only got a spurt of a couple kW to get started, right? So you're adding a lot more heat than this thing was designed for. So that's, it's not exactly deceptive, but it's a application specific rating that doesn't really apply to e-bikes or anything, that's a land moving vehicle with a human being on it. So you do need to take this into account of, how is the thing rated versus what's your application. I mean, I don't know of a single e-bike that's ever operated off a single cell, so you can just kind of chuck that, chuck those ratings out the window. Actually, copper wires are kind of rated in a certain particular way that, if you were to go look up for electrician's reference on, what gauge wire to use, you might be mistaken a little bit. Because when they design like the electrical wiring in a house, you need to account for maybe somebody's got a electric oven and it's pulling 2 kW out of the wall for 8 hours while they're cooking Thanksgiving turkey, right? And in addition to that, they've got an electric heater going off and on, and this sort of thing, these extreme loads might go on for 24 hours because as soon as they're done cooking the turkey, maybe it's time to do the laundry and run the dryer, which might also draw 2 kW. So it's not like the ratings on our e-bike. So a wire like this, this is about a 10 gauge. This might be rated for like 20 or 30 amps by official source for electricians. And if you wanted to run 50 amps, they might tell you to run a wire about this size. This is, maybe 6 gauge or so. But on our e-bike, we can actually get away with this at, the 50 or 60 amps for maybe an hour, because, it doesn't reach that critical heat point where it's about to melt off the, the insulation and then short or something like that. So our app, you do have to think about our application versus how things are rated. Oftentimes it's very different, especially if you're taking a component that's not normally used in an e-bike and then adapting it to an e-bike or e-motorcycle or something similar to that, or even like a e-skateboard, same thing, so yeah, hopefully this will, inform some people or at least amuse them, and maybe end a couple internet debates. If you have any criticism or hopefully constructive of what I've had to say, I'd really love to hear it. Definitely be skeptical of how things are rated, though, because there's just a lot of BS out there, and competitive forces and things like that in the market. One thing you should learn to sort of suss out some BS is to understand the terminology in things like dynographs and battery cell data sheets. Because if you don't understand that, then you might be open to some deception by somebody who's taken select bits of that data and then presented it to you as a whole picture, right? I mean, this happens all the time in like almost every form of marketing where, someone's cherry picking things. And you will find that in a lot of the battery cell specification sheets that they actually list their methodology for testing the battery. Sometimes they leave certain things out. It just depends on how honest the company wanted to be that day. But if you see that things are left out that were on other data sheets, you should probably be skeptical, because maybe they didn't want to talk about that bad part of the cell, or even same thing with the motor. It's like it might be running at the exact RPM that a 20-inch wheel is, and you're expecting a 26. So read between those lines, people. Anyway, yeah, I'm done rambling. Hopefully this has been helpful to you, and maybe in a month or two we might have some cool e-bike stuff to show. All right, peace.